All right, in chapter 1, section 6b, we're going to solve radical equations and equations that have rational exponents. All right, to solve radical equations, we first want to isolate the square root, and the opposite of a square root is a square, right? So then once we get that done, we're going to square both sides of the equation and then solve whatever's remaining. All right, the biggest thing here is you want to make sure that your answers are actually valid solutions. All right, so you want to check all of your answers, meaning when you plug it back in, you might get a no solution for some of these, right? Maybe you do all of the math correct, you just get an answer at the end that just does not work. All right, so think about the same thing as I did with like rational exponents, right? So something like 1 over x plus 1, right? Maybe we remember this value of x, it cannot equal -1, right? Because that's going to make our denominator 0. Now let's think about if I had the square root of x, right? What values can these not be, right? These all have to be bigger than or equal to 0, right? Because I can't have any negatives, right? So no negatives. I don't want any negatives under the radical, nor do I want the square root of x to equal a negative number, right? That's also not okay, right? I can't have, maybe when you plug it back in, you do get a positive underneath the radical, but it's going to end up equaling a negative, right? And you don't want that to happen, right? So that's why we want to check all of our answers, right? Some of these get a little bit tedious, but we'll start pretty simple and then we'll get a little bit harder as we go along. All right, so let's start with this first one. It looks like for this first one, we have a square root, but I have something else with that square root, right? So again, the first thing is I want to isolate the square root. So whatever has the square root, I want by itself. It looks like the easiest way to do that is I can add this entire square root to the other side of the equation. So I get plus 15, the square root of 15 minus 2x on both sides. And then doing that is going to get us an x equals the square root of 15 minus 2x. All right. And then from here, it looks like what I can do is I can square both sides, right? Once you get the square root by itself, square both sides, because the square root and the square, they're inverses of each other. They cancel each other out. So you end up with an x squared equals 15 minus 2x, right? Now we don't have any more square roots. This just looks like a regular quadratic equation, all right? And so to solve a quadratic equation, all right, I can set it equal to 0. All right, so we're just solving whatever's left over, and then you end up with an x squared plus 2x minus 15 equals 0. And it looks like we can factor this. Factors of -15 that add to a 2 is going to get you a positive 5 and a -3. All right, so then my answers are right up here is going to be an x equals -5 and an x equals 3, all right? You do want to check these though, right? You do want to check and make sure that these do get you valid solutions, right? So the check here, it might be a little bit more rigorous than if we had like a rational equation from before, right? All you were checking was that you don't get 0 on the bottom. Here, there's a couple different cases where you might get some strange answers, right? So I'm going to start with this first one. If I plug in -5, right, I'm going to check my answers now, right? If I check x equals -5, right, we get a -5 minus the square root of 15 minus 2 times -5 equals 0. And then it looks like we get -5 minus the square root of 25, right? When you go ahead and simplify all of that, you get 25. And then so the square root of 25 is 5. So I get -5 minus 5 equals 0. That means we get -10 equals 0, right? That's fully solved, but it's false, right? So that means x equals -5 is not a valid solution, right? I can try the exact same thing for x equals 3, right? Let's see if 3 works. All right, so it's going to be a 3 minus 15 minus 2 times 3. That's going to get us a 3 minus the square root of 15 times 6, which is going to get us 3 minus the square root of 9, which is 3 minus 3, and that is 0, right? That was what we had equal to in the beginning. So 3 is a valid solution. All right, so these might get a little bit tedious. You see all that work that I have for check. Honestly, it looks a little bit more than what I did when I actually got my answers. All right, so that's what makes this lesson a little bit tedious. Sometimes even going through the process of these questions, it gets a little challenging, and then you have to go back and check. All right, so one thing to keep in mind, right? Just pace yourself, make sure that you're getting everything done in a good amount of time. All right, this one's a typo, right? That square root shouldn't be over the equal 0, right? So it should just end there. All right, but it's the same exact idea, right? So you want to isolate the square root. So it looks like to do that, I can add the square root of 3x plus 18 on both sides. And then once we do that, I get an x equals the square root of 3x plus 18, right? So again, the goal here is to get the square root by itself. Once we get the square root by itself, I can square both sides. And then doing that is going to cancel out the square root. So we end up with an x squared equals 3x plus 18. And then I can set this equal to 0 and factor it. All right, I can subtract 3x, subtract 18. And so I end up with an x squared minus 3x minus 18 equals 0. And so this is going to get us an x minus 6 and an x plus 3 equals 0. All right, and so I get x equals 6 and x equals negative 3 as our answers. All right, so now I just want to check and make sure that these are valid answers, right? So I'm going to go off to the side over here and I'm going to check my answers. All right, so let me do the check up here. All right, so I'm going to check x equals 6. All right, let's just see if this one works. I'm going to do a 6 minus the square root of 3 times 6 plus 18 equals 0. So then I get a 6 minus the square root of 18 plus 18 equals 0. So I get a 6 minus the square root of 36 equals 0, and the square root of 36 is 6, right? And then 6 minus 6 is indeed 0. Right, so 6 is a valid answer, right? That one does work. Now, if I check x equals negative 3, let's just see if that works as well. So negative 3 minus the square root of 3 times negative 3 plus 18 equals 0. So it's going to be a negative 3 minus the square root of negative 9 plus 18 equals 0. So I get negative 3 minus the square root of 9 equals 0, and the square root of 9 is 3. Negative 3 minus 3, however, is negative 6 equals 0. So I know that this is not going to work. So our only valid answer here is 6. All right. Now you maybe noticed that first question kind of had something similar happen, right? Maybe you noticed the negative answer didn't work, right? You don't want to rely on little things like that. Sometimes the negative answer does work. Sometimes both answers work. Sometimes neither answer works, right? So that's why you need to check all of it, right? Check both of the answers that you get and make sure that they work. And if they don't work, then you have no solution. You have one solution, right? Those are different kind of cases that you might see. All right, so let's try the same thing with this one, number 3, right? And it looks like number 3, we already have the square root on one side of the equation and everything else on the other. So I'm going to go ahead on both sides of the equation. I'm going to square this side and square the other side. All right, the square root and the square are going to cancel out. And so we end up with a 4x plus 13 equals 2x minus 1 squared. All right, so then we end up with a 4x plus 13 equals, when you square this binomial, you can remember your special product or you can FOIL it. Either way, we should get 4x squared minus 4x plus 1. All right, and then you do want to set this equal to 0, so I'm going to subtract 4x on both sides and then subtract 13 on both sides. And so we end up with a 4x squared minus 8x minus 12 equals 0. All right, so now we want to try to factor this if we can. All right, so it looks like we can divide by a GCF of 4. Right, so let's just do that from the beginning just to make our remaining equation easier. So this is going to be an x squared minus 2x minus 3 equals 0. And then factoring this, I get an x minus 3 and an x plus 1 equals 0. And so I get x equals 3 and x equals -1, right, as our two answers, right? You do want to go back and check, right? So I'm going to check on the side here. I'm going to check x equals 3 and see if this works. So I get the square root of 4 times 3 plus 13 equals 2 times 3 minus 1. And so I end up with the square root of 12 plus 13 equals 6 minus 1, which is the square root of 25 equals 5. That does work, right? Because the square root of 25 is 5. So 3 is one of our valid answers, right? Let's try the same thing with -1. All right, so I'm going to get the square root of 4 times -1 plus 13 equals 2 times -1 minus 1. And then so this is going to get us the square root of -4 plus 13 equals -2 minus 1, which is -3. And on the other side, we get a 9. This does not work, right? The square root of the square root of 9 is just 3. It's not -3. All right, so that means -1 is not a valid answer, right? It's just 3. All right, so let's try the exact same thing with the next one. Again, tedious process, but it's the same process, right? I want to get the square root completely by itself. And it looks like over here, to get the square root by itself, I just need to add the 1 on both sides. And so I end up with the square root of 6x plus 7 equals x plus 2. All right, and then just like before, now that I have the square root by itself, I can square both sides. I get a 6x plus 7 equals, this is going to get us, when you FOIL it, an x squared plus 4x plus 4. All right, I can go ahead and subtract 6x on both sides, subtract 7. And then we're going to try the same thing. This is going to get us an x squared minus 2x minus 3 equals 0. So then you end up with an x minus 3 and an x plus 1 equals 0. So then we get an x equals 3 and an x equals -1. All right, looks like it's exactly the same as we got in the previous one, but let's just check if these work. All right, because maybe the solutions that work are going to be different from another problem. All right, so I'm going to check up here. All right, let's check x equals 3. All right, it's going to be the square root of 6 times 3 plus 7 minus 1 equals 3 plus 1. So this is going to get us 18 plus 7 minus 1, which is square root of 25 minus 1, so 5 minus 1. So 4 equals 3 plus 1 is 4, right? So then I can just bring that down, right? 4 does equal 4. So 3 does work. All right, let's try the same thing with -1. All right, so I get the square root of 6 times -1 plus 7 minus 1 equals -1 plus 1. All right, so this is going to get us -6 plus 7 under the square root minus 1. That's the square root of 1 minus 1. So 1 minus 1, right? 1 minus 1 is 0. Equals, and then -1 plus 1 is also 0. So I get 0 equals 0. This does work, right? So this time both of them work, right? You don't want to always rely on one of them working so the other one shouldn't, right? That's not always the case. Sometimes both of them work, sometimes none of them work. All right, so we should be checking all of them. Now, for the sake of the test, your upcoming test, and we'll tell you more information about it as we get closer to the date. But, right, I know that we're covering a lot of sections. A lot of these do get a little time consuming. If you feel like you're running out of time towards the end, right, save the check for the end, right? I care more that you're able to get these answers than if you can check if they're valid, right? You can do that at the end, and you maybe only lose a point, right? For example, if it's extraneous and you count it as an answer, right? But that's way less points that you're going to lose than if you just don't have time to answer a question completely, right? So just keep that in mind. All right, let's keep going with some examples. Now, the examples on this page are going to be a little bit more involved. You might see that I'm kind of going to take up this whole screen with work, right? Because if you have two square roots in a singular problem, then you're going to do the same process, but you might have to repeat it a couple times, right? So you want to get one of your radicals by itself, right? Square both sides, just like before. But only this time when you go to do that, you're not going to be, like, just doing it once is not going to clear the radical. It might clear one of them, but we need to clear both of them, right? So let's look at this one right here, right? So I have two square roots. I want to get one of them by itself. So I'm just going to move this one, right? So why don't we move this square root of x plus 1 to both sides, all right? All right, and then what that's going to leave us with is a square root of 2x plus 3 equals a 1 plus a square root of x plus 1. All right, and now I can go ahead again, square both sides. So I'm going to square and then square, right? The square and the square are going to cancel over here, so I'm going to be left with a 2x plus 3. And then on the other side, this is the same as if we were to write it twice and FOIL it. All right, so this is the same. I'm gonna actually write it this time. It's gonna be 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. Right, and I'm gonna treat the square root of x plus 1 as its own thing, right? So I'm gonna FOIL the first times the first. It's gonna be 1 times 1, so 1. And then 1 times the square root of x plus 1 is going to be 1 of these things, right? It's going to be 1 square root of x plus 1. And then inner times the inner is going to be another one of these things. So I'm going to go to 1 square root of x plus 1. Now if I do the square root of x plus 1 times the square root of x plus 1, that's the same as the square root of x plus 1 squared, which is the same as just x plus 1. All right, if that's confusing, let me just write out the square root of x plus 1 squared, right? So I have the same thing twice, I'm squaring it. And then I still have 2x plus 3 on the other side. That didn't change at all, right? And then I can combine like terms, right? Looking at these two things right here, right? The square root of x plus 1 is kind of our like term in this case, right? So if I have two of these that are being added together, that's just going to turn into 2 square root of x plus 1s, right? If I have 1 plus another one, then we get 2 of those things. All right, so then I'm going to get 1 plus 2 square root of x plus 1, and then the square root of x plus 1 squared is just going to become x plus 1. And then on the other side, I'm still just going to have the 2x plus 3. All right. And then I can combine like terms. So this is going to get me a 2x plus 3 equals 1 plus 1 is going to get me a 2. And then nothing combines with that x, so I'm going to get a 2 plus x plus 2 square root of x plus 1, all right? So looks a little bit better, but again, we want to get that radical by itself. We got one of them by itself, right? So we got this one by itself. I want to get the other one by itself now, right? I want to get this one by itself, right? So let's subtract 2 and subtract the x, right? In doing that, I'm left with an x plus 1 equals 2 square root of x plus 1. Let's divide by 2. And then we're left with x plus 1 over 2 equals the square root of x plus 1. All right, and then now once again, I can go ahead and square both sides. All right, so then doing this, I get the square root of x plus 1 squared. That cancels out. So now after this step, right, we have finally gotten rid of all of our radicals, right? And then over here, this is the same as if we were to square the top, square the bottom. So this is the same as x plus 1 squared over 2 squared equals x plus 1. And then let's just simplify this, right? The square of a binomial, you can do that off to the side. Is we're just going to FOIL it, right? So x plus 1 times x plus 1, right? FOIL that. All right, it's just going to get us x squared, once we do that whole process, plus 2x plus 1 over 4 equals x plus 1. All right, and then now I just want to solve for x. All right, so we end up with a rational equation. To get rid of that 4 on the bottom, I can multiply both sides by 4. All right, if we don't like that fraction, keep in mind our least common denominator here is 4, right? Even if I did this this x plus 1 over 1, right? You can multiply the top and the bottom by 4, and that gets rid of that fraction. All right, so then those cancel out, and so you're left with an x squared plus a 2x plus 1 equals a 4 times an x plus 1. distribute that 4, and then you're left with an x squared plus 2x plus 1 equals 4x plus 4. Let's get everything to one side, right? This is a quadratic, so minus 4x and then minus 4. And then we're left with an x squared minus 2x minus 3 equals 0, right? This is factorable, so we end up with x minus 3 and an x plus 1 equals 0. And then when we get our two answers, it's going to be x equals 3 and x equals negative 1. All right, wow, right? A lot of work, all right? But we are not finished, right? I'm sorry to say we're not finished, right? We do need to check and make sure that these are valid solutions. So I'm going to do the check up here, right? So, right, again, look at all this work, right, for this one problem. I'm going to check up here. Let's check, right? The first one that we want to check doesn't really matter. Let's check 3, right? So I'm going to check x equals 3. So I'm going to plug x equals 3 into the original problem, and it's going to be the square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. And then 2 times 3 is 6. 6 plus 3 is 9, so I get the square root of 9 minus the square root of 4 equals 1. So 3 minus 2 equals 1, right? That does work, right? 3 minus 2 is equal to 1. So x equals 3 is a valid answer. So let me circle that, all right? Or box it, whatever. All right, and then I want to check x equals negative 1. All right, let's see if this one works. So I'm going to get a 2 times negative 1 plus 3. And then I'm going to get minus the square root of negative 1 plus 1 equals 1. Let's see if this works, right? So then here I get the square root of negative 2 plus 3 minus negative 1 plus 1 is 0. Square root of 0 is just 0, and negative 2 plus 3 is 1, and the square root of 1 is 1. So I get the square root of 1 minus 0 equals 1. I get 1 equals 1, right? That does work. So both of these actually work, right? A lot of work to get our final answer, right? I know that this was really tedious, all right? Sometimes there's times where you have to do it multiple times to get your radical by itself, right? Even if there's two of them, right? When you see two radicals, that's a little tricky, right? And it's not exclusively two radicals, it's two radicals with something else that's not a radical, right? So in this case, it was that 1, right? This 1 kind of gave us issues, right? If it wasn't there, then we probably would have been able to do this a lot more simple, right? All right, but let's try the exact same thing with the next one. All right, so once again, I see two radicals. I want to just get one of them by itself, right? So it doesn't really matter which one we do, but the one that's already negative might be a little bit easier to move, right? If I just add it to both sides, then that's going to make one of my radicals already isolated, right? So then adding the square root of x minus 3 is going to get rid of it on this side, right? And then you're left with the square root of 2x minus 5 equals, it's going to be 1 plus the square root of x minus 3. All right. And then we can do our squaring step, right? We square both sides. So I'm going to square the left, square the right. All right. And then on the left side, the square root and the square are going to cancel out. And so you're left with just the 2x minus 5. All right, equals. And then this entire side squared, it's the same as if we write it twice and FOIL it. So it's going to be 1 plus the square root of x minus 3 times 1 plus the square root of x minus 3. All right, and then we can FOIL. 1 times 1 is 1. 1 times the square root of x minus 3 is 1 square root of x minus 3. All right, and then the square root of x minus 3 times 1 is 1 square root of x minus 3. And then the square root of x minus 3 times the square root of x minus 3 is the square root of x minus 3 squared. All right, equals 2x minus 5. All right, and then we can combine like terms and then simplify that square. So that's going to get us a 2x minus 5 equals 1 plus, right? Again, just like before, I have two of these exact same radicals, so I'm going to have 2 radical x minus 3. all right? And then plus x minus 3 squared is just x minus 3, all right? And then so we can combine like terms. This 1 and this negative 3 are going to combine to make a negative 2. So I get a 2x minus 5 equals negative 2 plus 2 square root of x minus 3, and then I have that plus x, all right? And then again, I just want to get that square root of x minus 3 completely by itself now. So I can add 2 on both sides, and then I can subtract x. And then you're left with an x minus 3 equals 2 square root of x minus 3. And then to get it completely by itself, again, let's just divide by whatever's in front of it. So let's divide by 2, and then you're left with x minus 3 over 2 equals the square root of x minus 3. All right, so that was a lot just to get one radical by itself, right? But now we have to do the exact same thing, and I'm going to square both sides. And then squaring both sides, I can square the top, square the bottom. So this is going to become the x minus 3 squared over 2 squared equals the square root of x minus 3 squared. Or I'm sorry, wait, actually doing that got rid of the square root, right? So this just becomes x minus 3. All right, and then simplifying the left-hand side of it, again, we can FOIL x minus 3 squared on the side, right? You guys can verify that if you need to, but that's going to leave us with an x squared minus 6x plus 9. Right, again, if you don't know how I got that, right, just FOIL that. Right, we're just foiling it to get that. Over 2 squared is going to get you 4 equals x minus 3. All right, and then once again, to get rid of that 4 on the bottom, I can multiply both sides by 4. Right, or you can think of it as x minus 3 over 1, find a common denominator, multiply by 4. All right, so if I multiply by 4 on both sides, then these are going to cancel. All right, and then we get x squared minus 6x plus 9 equals, I can distribute 4 over here, that's going to leave me with a 4x minus 12. All right, and then I can get everything on one side, set it equal to 0, so I'm going to subtract 4x, add 12, and then I'm left with an x squared minus 10x plus 21 equals 0, and then I get an x minus 7 and an x minus 3, right? This does factor, and so I get an x equals 7 and an x equals 3. Again, a lot of work. We do want to check our answers now, though, right? So I'm going to check up here. All right, so I'm going to check x equals 7, right? Why don't we try that first? I'm going to plug it into the original. So I get the square root of 2 times 7 minus 5 minus the square root of 7 minus 3 equals 1. 2 times 7 is 14, and 14 minus 5 is 9. So I get the square root of 9 minus 7 minus 3 is 4. Square root of 4 equals 1. So I get 3 minus 2 equals 1. That does work. So x equals 7 is a valid answer. I'm going to circle that one, or box it. All right, and then x equals 3. Let's check that one. So it's going to be 2 times 3 minus 5 underneath the radical. And then I get a minus the square root of 3 minus 3 equals 1. Right, 3 minus 3 is 0. So we get 6 minus 5, which is 1. So the square root of 1, which is 1, minus 3 minus 3 is 0. Square root of 0 is just 0. And I get 1 minus 0 equals 1, which does work as well, right? So I get x equals 3, right? Both of these work, all right? Really long and tedious process, right? You can see all the work that we did for these kinds of problems, right? These are about as hard as the radical equations get, right? But hopefully we see the steps the steps themselves are not extremely difficult. It's just time consuming, right? And it takes a lot of work, right? Be careful with your steps, right? Little silly mistakes might set the entire problem back, right, a good few minutes, right, if you make those little mistakes at the very beginning, right? Try to avoid that, right? Go through it in a way that you can understand it, and so that you don't make those little silly mistakes. All right, so let's try the exact same thing over here. All right, I know it's a lot of work, but let's just keep trying it, right? Some exactly like that, right? The more you do them, the easier they might get. all right? Here we already have one of our radicals by itself, right? So I don't need to move things around, right? So I'm just going to go ahead and start by squaring both sides, right? When we square both sides, on the right-hand side is where the radical cancels out, and on the left-hand side is where we're going to have to FOIL, right? So that's going to become square root of x plus 5 minus 2 times another square root of x plus 5 minus 2 equals x minus 1. All right. And then once again, just like before, you can try to FOIL, right? These square roots are going to become their own thing. So I'm going to make that into the square root of x plus 5 squared. All right. And then I got the square root of x plus 5 times negative 2, which is going to be the negative 2 square root of x plus 5. All right. And then I get negative 2 times the square root of x plus 5 again. And then negative 2 times negative 2 is 4 equals x minus 1. All right, square root and the square cancel over here, so I get an x plus 5 minus 4, right? Now we have 4 of these things, right? I have 2 over here, 2 over here, and that becomes 4, right? So I have 4 of these square root of x plus 5s, all right? And this is going to equal, oh, actually, just kidding, we have a 4 here, right? So plus 4 equals x minus 1. All right, we can combine like terms. So this is going to get us an x plus 9 minus 4 square root of x plus 5 equals x minus 1. All right, and then I can subtract x, subtract 9, and so I get negative 4 square root of x plus 5 equals, these x's cancel out, equals negative 10. Right, so you see that this actually is probably going to be a lot simpler than it was before, right? Because we don't have a binomial expression that we're going to have to square again, right? It's because from here what we can do is we can just divide by negative 4, just like normal, all right? And then we're left with something that's not extremely complicated to square, right? And then negative 10 over negative 4, simplifying that is going to get us a 5 over 2, all right? And then all I have to do is square 5 over 2 instead of squaring like a big binomial with a number on the bottom and then having to get rid of that, right? So just because it looks like this doesn't mean it's always going to take forever, right? It's still a little tedious, but hopefully you see it's not as long as some of the ones in the previous page, right? So then I get x plus 5 equals 5 over 2 squared is going to get you 25 over 4. Subtract 5 on both sides, and this is going to get me an x equals 25 over 4 minus 5. This is the same as 5 over 1. I do want a common denominator just so that we're able to combine these effectively. And then I get x equals 5 times 4 is 20, and then 25 minus 20 is 5. So I get x equals 5 over 4. All right, let's just see if this works now. Right, so a little bit less work than some of the other ones, but still a decent amount of work, right? Let's check it now. So I'm going to check it up here. And it's going to be 5 over 4 plus 5 under a radical minus 2 equals the square root of 5 over 4 minus 1. All right. So always plug it into the original. And then this is going to get us, when we simplify this, right, over 1 times 4 times 4. 5 plus 5 times 4 is 20. It's going to get us 25 over 4. Whoa, you cannot see that at all, right? All right. Minus 2 equals 5 over 4 minus 1. I can turn this into 1 over 1, and then times 4 times 4. And then 1 times 4 is 4, and then 5 minus 4 is 1. So I get the square root of 1/4. All right. Square root of 1/4 is just going to get us 1/2. All right. I can square root the top, square root the bottom. And then 25 over 4, the square root of that is going to get us 5 over 2. Right? Again, square root the top, square root the bottom. And then when I subtract 2, I get 2 over 1 times 2 is going to get us 5 minus 4 over 2 is 1/2, and then 5 minus 4 is 1. So we get 1/2 equals 1/2. This does work. This is a valid answer. All right. So again, a little tedious, hopefully a little bit better than the last one though, but still a decent amount of work, right? Let's try the exact same thing with the next one. All right. So over here, once again, I have a square root on one side. It's already isolated, so I can just jump right into squaring both sides. And then in doing this, the square root and the square cancel out. I get a 4x plus 1 equals, I can square this by writing it twice and foiling it. So I get the square root of x minus 1 plus 2 times the square root of x minus 1 plus 2. All right, so I get 4x plus 1 equals, foiling this, I get the square root of x minus 1 squared. All right, plus 4 square root of x minus 1. I'm sorry, I kind of jumped a step. All right, so it's going to be plus 2 square root of x minus 1 plus 2 square root of x minus 1. And then 2 times 2 is going to get you 4. Right, so that's after foiling it. And then so we end up with 4x plus 1 equals x minus 1. Plus these two radicals are going to combine and we're going to get a 4 square root of x minus 1. And then I still have that plus 4. All right, so I can combine like terms again. This is going to get me a 4x plus 1 equals x plus 3 plus 4 square root of x minus 1. And then I can subtract x and then subtract 3. And this is going to get me a 3x minus 2 equals 4 square root of x minus 1. And then lastly, I can divide by 4. And then so I get 3x minus 2 over 4 equals the square root of x minus 1. All right, and then just like before, I can square both sides of this. And so I end up with 3x minus 2 over 4 squared equals x minus 1. All right. And then we can square the top. You can FOIL it off to the side if you need to. This is going to get us a 9x squared minus 12x plus 4 over 4 squared is 16 equals x minus 1. And then once again, just like before, I can multiply both sides by 16. And so we end up with a 9x squared minus 12x plus 4 equals 16 times x minus 1. And so I can distribute that 16, and so I end up with a 9x squared minus 12x plus 4 equals 16x minus 16. And then just like before, let's get everything to one side and set it equal to 0. All right, and so doing this, I get a 9x squared minus 28x plus 20 equals 0. And then let's just see what factors of the first times the last. So 9 times 20 is 180. I need factors of positive 180 that add to negative 28. And I actually think this is fairly simple, right? We end up with a negative 18 and a negative 10, right, to get us that negative 28. All right, so we can do our slide and divide. So I'm going to do x minus 18, x minus 10 equals 0. Because there's a 9 in front, I'm going to divide by 9. So I get an x minus 2. And then on the other side, I can slide that 9 out front. I'm going to get a 9x minus 10 equals 0. All right, and then solving each of these, I get x equals 2 and x equals 10 over 9. All right, so then I can now check these answers. Let me go back to the top and check them. All right, so I'm going to check. Let's start with the easier one. I'm going to check 2. All right, it was a positive 2? Yeah, it was a positive 2. So I'm going to check x equals 2. So it's going to get us a 4 times 2 plus 1 equals square root of 4 minus 1. I'm sorry, not 4. 2 minus 1 plus 2. Right? And so you end up with 4 times 2 is 8 plus 1 is 9. I get the square root of 9 equals square root of 1 plus 2, which is 3 equals 1 plus 2. Right, that does work. So then x equals 2 is a valid answer. Or I can try the exact same thing with 10 over 9. Right, so then I'm going to get 4 times 10 over 9 plus 1 equals the square root of 10 over 9 minus 1 plus 2. And so we end up with 40 over 9 plus 1, right? 1 is the same as 1 over 1, so I can multiply the top and the bottom by 9. And so we end up with, on this side, 49 over 9 under the square root. And then 10 over 9 minus 1, this is the same as 1 over 1. I can times by 9 on the top and on the bottom. And so I get the square root of 1 over 9 plus 2. And so over here, I get 7 over 3, right, when you square the top and the bottom. Here, I get 1 over 3 plus 2, which 2 is the same as 2 over 1. I can times 3 on both sides, and I get plus 6 over 3. And so I get 7 over 3 equals 7 over 3. All right, this does work. All right, so both of these are valid solutions. All right, very tedious process, but that's the process for how you solve these kinds of problems. Let me zoom out. All right, and now other kinds of radicals that you might see are maybe cube roots, fourth roots, fifth roots, right? Things like that. If it's any other root that's not a square, you just raise both sides to the same power as the index, right? So it would be the exact same process, but like let's say I had, I don't know, the cube root of x equals 2. I just have to cube both sides, right? And then I get x equals 8. All right, something like that, right? That's a very simple example, right? But in general, that would be the same process, right? What you would cancel out the index with an exponent of that power, right? And if you have a fractional exponent, then you would raise it to the power of the reciprocal. What I like to do in these kinds of examples is first take the root, and then I raise it to the exponent of the denominator, right? Maybe a little bit confusing in words, but let me just give you like x to the 2/3 equals, I don't know, I'll say 16, right, for example. All right, if you're trying to solve something like this, right, if you do the power of the reciprocal, so 3/2, right, that does cancel out this exponent, right, because power to a power you multiply, and then 2/3 times 3/2, if you multiply by the reciprocal, you get 1, equals 16 to the 3/2, like this. You would simplify like normal, right? So you would move the 2 up front as the index, so I get x equals the square root of 16 to the 3rd power, which is 4 to the 3rd power, which is 64, right? But what some people might miss with something like this is that there's also a negative number that works as a solution, right? So what I like to do, I'm going to rewrite the exact same thing. So I'm going to say x to the 2/3 equals 16, right? Think about what I did in the previous lesson where I kind of split up that exponent and I kind of treated it as two different things, right? So keep in mind, this denominator can be written as the index of our radical. So it's going to be the cube root of x all to the 2nd power equals 16. Or you can think about it like I did in the previous lesson, as x to the 1/3 to the power of 2, right? But either way, right, no matter how you think about it, right, you're going to have to end up getting rid of an exponent of 2 by square rooting both sides, right? That's essentially how you get rid of that exponent right there. And then that's what some people might miss, right? They might miss the fact that there's a plus minus here hidden in this problem, right? So I get a cube root of x equals plus minus the square root of 16, which is plus minus 4. All right, and then when I go to cube both sides of this problem, then I get x equals -4 to the 3rd power, and I get x equals +4 to the 3rd power, right? But remember that odd exponent is going to get us whatever sign we see, so it's going to get you -64, and it's also going to get you a +64, all right? So yeah, a lot of context that you might need when solving these kinds of problems. But hopefully that clears up some of the confusion. I know some of you had like issues on the homework. On WebAssign, maybe you were getting one answer and you know you did the process right, but maybe you forgot the negative, right? This is typically why. All right, let's try some examples, right? So this very first one here on this page, all right, it might look kind of crazy, but again, right, just get one of your radicals by itself. So I'm going to go ahead and move that cube root of x to both sides. And then that cancels it out over here, and then we get a cube root on one side, and then another cube root on the other side equals the cube root of x. All right, and now the opposite of a cube root is if we cube, right? So I'm going to go ahead and cube both sides of this. All right, so then this cube root and the cube cancel out on both sides of this actually, and then you end up with a 4x squared minus 4x plus 1 equals x. All right, so then I can go ahead and solve this like normal, right? I'm going to subtract x on both sides. I get 4x squared minus 5x plus 1 equals 0. All right, and then you can just factor like normal, right? Factors of 4 that add to -5 are -4 and -1. So I can x minus 4, x minus 1. There's a number in front. Let's divide. And then just slide whatever goes over. So then I get an x minus 1. And then a 4x minus 1 equals 0. And so I get an x equals 1 and an x equals 1/4. All right? And these are both valid solutions. Now, in some cases, you don't need to check, right? You can if you want to be absolutely certain, but in some cases, it's easier if you just use some number sense, right? The only reason why some of the other problems would have gotten us an extraneous solution is if maybe we got like a negative underneath the radical, or we got something equal to a negative, right? Something like that. That really won't be an issue when we have a cube root, right? Because we are allowed to cube root negative numbers and get negatives out of it, right? So, like for example, the cube root of -8 is -2, right? So we got a negative answer that was perfectly fine in this case, right? So certain cases we don't really need to bother checking. All right. So now let's do the same thing over here, right? Same exact idea, we just have a fractional exponent this time. But once again, let me just get whatever has the fractional exponent isolated. All right, so I'm going to add 4x plus 2 to the 1/3 on both sides of this equation. And then so we end up with a 3x plus 7 to the 1/3 equals 4x plus 2 to the 1/3. And then you can go ahead and cube both sides, right? The denominator here is 3. So if I raise both sides to the 3rd power, that's going to cancel out that exponent. So then I end up with a 3x plus 7 equals 4x plus 2. All right, and then you can just solve like normal. So we can subtract 3x, subtract 2, and then I get 5 equals x. All right, again, cube roots are fine, right? We don't really need to bother checking these because negatives are really no concern for us, right? This is going to be a perfectly valid solution. All right, similar story over here, right? I get my radical to one side, everything else on the other side, all right? And in this case, right, I have a 4th root, right? But no big deal, right? It's already by itself, so I can raise both sides to the 4th power. That's going to cancel out this radical. So then I end up with an x squared plus 6x equals 2 to the 4th is 16. And then we just end up with a regular quadratic that we can factor and solve. So then again, x squared plus 6x minus 16 equals 0. And factors of -16 that add to 6 are a positive 8 and a -2. All right, so then I get an x equals -8 and an x equals 2, right? Even roots we do want to check, right? We don't want to get a negative answer out of these, right? So I can go ahead and plug these in. Let me check over here. All right, so I'm going to check x equals -8, and this is going to get me a -8 squared plus 6 times -8, and so we end up with 64 minus 48, and that's going to get us the square root of, I'm sorry, not the square root, this is 4th root, right? The 4th root of 16, which is 2, right? We get 2 equals 2. That is a valid answer. All right, so I'm going to do the same thing with x equals 2. All right, so this is going to get us 2 squared plus 6 times 2, which is 4 plus 12, which is 16. So I get the 4th root, keep forgetting to write it, right? 4th root of 16, which is 2, right? Both of these do work, right? They're both valid solutions. All right, we can try the exact same thing over here. Again, if I see an exponent of 1/4, right, the opposite of 1/4 is 4. All right, so let me go ahead and raise both sides to the 4th power. This is going to get us a 3x squared plus 52x equals 4 to the 4th power. You can check if you need to. I already know that this is going to be 256, but again, you would just do 4 times 4 times 4 times 4. All right, 4 times, right? And then I can subtract 256 on both sides. And so you end up with a 3x squared plus 52x minus 256 equals 0. All right, so then we want to try to factor this if we can, or use quadratic formula, right? But this is going to get us 3 times negative 256 is going to get us negative 768. I need factors of negative 768 that add to 52. All right. I've already done this problem, right? So I know what the answer is going to be. It's going to be a 64 and a negative 12. Obviously, on a time crunch, during a test or a quiz or anything like that, I mean, you're going to get things that you'll be able to do in a short amount of time, right? Just because this lesson is pretty intense as it is, and on your test, you're going to have plenty more lessons that are going to be equally time consuming, right? So we don't want to try to overwhelm you guys with really crazy big numbers, right? Even if you decided to use the quadratic formula for this one, right, it would maybe take a really long time, right? I would rather test the concepts versus can you work with humongous numbers, right? But these are the numbers that you're going to end up with for this problem. So it's going to be an x plus 64 and then x minus 12 equals 0. And then I can divide both sides by 3. And so we end up with a 3x plus 64 equals 0, and then x minus 4 equals 0. And so I get x equals negative 64 over 3, and then an x equals 4. All right, so then you just want to check and make sure that these do work, right? These are kind of, again, this isn't going to be fun, right? But we can just check it. Check the harder one first. Let's get it out of the way. All right, x equals negative 64 over 3. All right, and this is going to get us 3 times negative 64 over 3 squared plus 52 times negative 64 over 3. All right, and then 64 squared is, again, I did this off camera already, but it's going to be 4,096 over 9, right, times 3, plus 52 times negative 64 is going to get you minus 3,328. Again, did it off camera. All right, and then over here, the 3 and the 9 are going to simplify it, so it's going to get you a 3. And then we can just simplify this as needed, right? It's going to be 4,096 minus 3,328 over 3. All right, and then subtracting this is going to get you 768 over 3. Now, when you simplify this, we should get 256. All right, and then I get 256. Keep in mind, all of this was under the exponent of 1/4. All right, and the fourth root of 256 is 4, right, which is what we wanted this equal to, right? So this does work, right? We can try the same thing with 4. So I'm going to get a 3 times 4 squared plus 52 times 4 equals 4, right? This is all to the power of 1/4, all right? And then 3 times 4 squared is, well, 4 squared is 16, and then 3 times 16 is 48. So then I get a 48 plus 52 times 4 should get you 208. All right, and then 208 plus 48 is going to get you 256. And then this does work, right? The fourth root of 256 is 4. All right, so these are both valid solutions. All right, so now let's try some where maybe there's not just one singular radical, or maybe the radicals look a little different. All right, here our rational exponents do not completely match, but we can still try it the same way, right? In this case, because these two have the exact same denominator, what we can try to do from the beginning is raise both sides to the 5th power, just to get rid of that denominator right away. And then notice that the 5's cancel out, and so we end up with an x minus 3 squared equals 4x to the 1st power, which is just 4x. all right? And then x minus 3 squared, when you go ahead and FOIL that, is going to get you x squared minus 6x plus 9, all right, equals 4x. And then you can subtract 4x on both sides, and then you end up with an x squared minus 10x plus 9 equals 0. And then I can factor this and solve. So I get an x minus 9, x minus 1 equals 0, and so I get an x equals 9, x equals 1. Once again, odd roots you don't have to check, right? These are going to be fine. These are going to be perfectly valid solutions, all right? And we can try the exact same thing with this last one, all right? Again, I want to try to get rid of these denominators. So I have a 4 here, and then I have a 1/2 over here. To get rid of that 4 and the 2, I can raise both sides to the power of a common denominator. And then over here, the 4's are going to cancel out, but keep in mind, this isn't already in parentheses, right? So 3x is not raised to the 3/4. It is just the x, all right? So this 4 is actually going to both of these values here, right? The 3 and the x to the 3/4. So this is the same as 3 to the 4th, and then x to the 3/4 to the 4th, right? That has to go to both of them, right? So hopefully we understand that difference, right? This was from way back in the beginning. It's not like 3x to the 3/4 like this, right? That 4 has to go to both of these, because that 4 isn't just canceling out this 4, right? It's going to both of them, right? So that's not what we have. We have something different, all right? So then this is going to leave us with 81 x to the 3rd, all right? And then on this other side, I don't have to worry about that because there's only one base here, and it's the x. And then 1/2 times 4 is going to get us an x squared. So then I can just subtract x squared and then solve as needed. So this is going to get us an 81 x to the 3rd minus x squared equals 0. I can factor out an x squared, and then you're left with an 81x minus 1 equals 0, and then I get an x equals 0 and an x equals 1 over 81, right? The fourth root we do want to check, and the same with the square root. So we can just check it briefly over here. It's going to get us a 3 times a 1 over 81 to the 3/4 equals 1 over 81 to the 1/2. Keep in mind, 1/2 is the same as a square root, and the square root of 81 is 9. So I get 1 over 9 over here. And then the 4th root, right, of 1 over 81 is 1/3. So I get 1/3 to the 3rd power with this 3 here, and this is going to get us a 3 times 1 over 27, which is 1/9, right? So I get 1/9 equals 1/9. This does work. And then if you plug in 0, we would just end up with 0 on both sides of the equation, right? So these are both valid solutions. All right, very tedious lesson, right? I know this video is kind of long, but these are all the cases that you might encounter along this lesson.